All right, you guys, today we're going to talk about proportional concepts. Now, the first thing that we're going to look at is our checklist for this week. So you should be working on 3 lessons. The first of which is proportion concepts. The second would be unit rates from a graph. And then the third is going to be proportional reasoning. Now, first, let's look at our vocabulary. Our first word is additive relationship. So now the first thing that I'm thinking of is addition. So these are going to actually be two quantities that are expressed or related to each other through addition or subtraction. So these are kind of those additive relationships that you saw in 6th grade, something that might look like y equals x plus 2 or y equals x minus 3. Notice we're not multiplying the x by anything, we are just adding or subtracting. The next one is a multiplicative relationship. This is a relationship where these two quantities are expressed as multiples of each other. So instead of addition and subtraction, this will be something like multiplication or division. So it could possibly look like y equals negative 3x, or even y equals 1/4 of x, which is really dividing x into 4 pieces. Multiplicative relationships, and this is going to be very important, are always proportional. Our next vocabulary word, which is actually new to 7th grade math, is rate of change. And a rate of change is something that describes how one thing changes in relation to another. So for example, 25 miles per hour. This would be a rate of change where I'm changing 25 miles every 1 hour. Our constant of proportionality, so notice proportionality, which means it's a multiplicative relationship, is the ratio between two directly proportional quantities. And we're actually always going to find that by putting y over x. Notice I use the letter k for this. K stands for our constant of proportionality. A proportional relationship is a relationship in which two quantities vary directly with each other. Most important thing to remember is that a proportional relationship has to be a straight line that always goes through the origin. So if it does not go through the origin, it is not going to be proportional. And even an example where maybe it goes through the origin, but it's not always a straight line, that would not be a proportional relationship either. Our last new vocabulary word is a linear relationship. This is an equation that makes a straight line, so a straight line relationship between a variable and a constant when it is graphed. So it's a relationship between x and y that when you put it on the coordinate plane, it forms a straight line. And we actually use y equals mx plus b. So this is new to 7th grade math. Notice we are multiplying x by a number, and then we are also adding or subtracting something at the end. So this is where we actually combine multiplicative and additive thinking. So our first example, an additive relationship. And this should be a review from the beginning of 6th grade when you did learn this. And 4th and 5th grade, these are kind of input-output tables. So our backpack weighed 4 pounds when I first bought it. After a few weeks, you have accumulated more supplies. What is the relationship between the total weight of the backpack and the supplies? So I'm noticing right off the bat that they didn't tell me how much it increased by each week. So I'm just going to say it's going to increase by 1 pound each week, just to help us out. So when I go down here and I'm trying to fill in my table, I have X, which is the weight of supplies, and Y, which is the total weight of the backpack. So when I first bought my backpack, I had 0 weight of supplies, and my backpack was already 4 pounds. Well, now my empty backpack now has 1 pound of supplies. So notice from 1 to 5, I added by 4. Now for the next week, I've added another pound. So now my total weight of my backpack is 6 pounds because I'm adding the 2 pounds of weight for supplies to the original amount of my backpack, which was 4 pounds. The same with 3 pounds, my backpack would totally weigh 7. And then if my weight of my supplies is 4, that means the weight of my entire backpack would be 8. So when you read below, it says something that is constant does not change and will stay the same. We used this word when we were solving equations. So in the scenario above, what value was the constant? The weight of the backpack or the total weight of the supplies? In this case, it's going to be our total weight of the backpack. So then to find the answer, I would add the weight of supplies. I would add 4, which represents the original amount of the backpack. I would add 4, and then I would add the weight of supplies to find my total amount. So I can come over here and I can make an equation. Y, which is the weight of my backpack, would have to equal whatever the weight of my supplies was plus the 4 pounds that my backpack originally cost. Notice this has a plus 4, and we look at the table, we have a 0 and a 4. If it goes through the point 0, 4, that means it does not go through the origin, which means it is not proportional. When we look at our next one, we have our multiplicative relationship. So again, this is multiplying and dividing. So to earn money for my allowance, my parents have agreed to pay me $2 each hour that I work on the weekends cleaning the house. So I'm going to fill in my table, and obviously if I work 0 hours, I am getting 0 money. Unfortunately, that is life. If I work 1 hour, then I will make $2. 2 hours, and I would make 4. 3 hours, and I would make $6. And for 4 hours, I would make 8. So notice to get from y to x every time, I'm multiplying by 2, which means I can come over here and make an equation. Y equals 2 times x, which is the number of hours. Since I am not adding or subtracting anything on the end, and I can see this point very clearly right there, that is the origin, this would be a proportional relationship. So which means that it would be a straight line that goes right through the origin. So now we want to finish our answers over here. So something that is constant does not change and will stay the same. In the scenario, what value is constant? The amount of money earned each week or the number of weeks? And this, I'm going to kind of harp on something constant. We have a constant rate of change in this problem, and our constant rate of change was that $2 I earned every week. I earned $2 every week, no matter what. So the only thing that was changing in this sense is the number of weeks. So as long as I continue cleaning, I will always earn that $2 per hour. Right, in which situation is the distance traveled proportional to time? I can see I left my writing over here. If I have an airplane during takeoff, if I'm thinking about the distance traveled over the time, here's my landing strip and here's my airplane. It kind of starts off slow and then it increases. So this does not have a constant rate of change, which means it won't form a line, which means it cannot be proportional. Then we have our speed when we take off for a roller coaster. So in the very beginning, you got to kind of chugga, 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 and then it rapidly increases. Well, I see right here, this does not form a straight line, and it also would not go through the origin. So I will cancel it out. A ball that is tossed up in the air and falls back to the ground. My speed when a ball goes upwards is very quick, very fast. But then it reaches this top point, and this top point over here, it doesn't have any movement for a second until it starts falling back down. And again, that's not a constant rate of change. It's not a constant speed. Then we'll look at our last one. A car ride at a constant rate of speed, and guys, this word right here, constant rate of speed, is super important, of 25 miles per hour for 8 minutes. Because that car is constantly going that speed, it would form a line and it would go through that origin. Because if I'm thinking about it, if I have traveled 0 minutes, then I have also traveled 0 miles. And that 0, 0 represents the origin. So this last one right here represents a proportional relationship. All right, now we want to drag each object to show which one has distance that's proportional to time in the situation represented. So now let's remember what we talked about last example. It has to be a linear relationship, so it has to form a straight line, which means it has a constant rate of change, and it has to go through the origin. So I'm going to look at this table first. I have distance and time. Now I know that proportional relationships are multiplicative, which means for this table, to get from 2 to 5, I multiply, excuse me, to get from 2 to 10, I would multiply by 5. If this is a multiplicative relationship, that means that pattern should continue. So then I should be able to multiply 4 by 5 to get this value. But I see right off the bat that that is not 20, which means that these are not proportional. So this one would go right here where distance is not proportional to time. I do want to take this moment to actually show you how we could find the constant of proportionality and how we could also prove this particular one is not proportional. If distance is x and time is y, just the way the table has been given to us, then I should be able to put every y over x and they should be equivalent. Well, 10 over 2 simplifies to 5. Does 14 over 4 simplify to 5? No, it does not. So then we're going to take this one and say it is not proportional. Now, a subway train that makes 4 stops in 12 minutes. If it is making stops, then we do not have a constant rate of change. So this one as well is not proportional to time. A person hiking up and then down a mountain. I really don't have enough information because I wasn't given any time or any distance. So we're going to say not enough information. Now our next graph. Well, I'm seeing right off the bat, that is a straight line and it goes through the origin. So I know that I need to draw my arrow all the way over here. Second to last one. A car driving at a constant speed for 30 minutes. Ooh, this word right here, constant speed. This gives us the A-OK that it is going to be proportional to time. Has a constant speed, and I know that if I'm traveling for 0 minutes, I have traveled 0 distance. Now, an elevator that stops at each floor for an equal amount of time. I'm given some information about time, but I know that they're stopping, which means that no matter what, there's not a constant rate of change. So I would have to arrow it to not proportional to time. All right. If the points on the graph represent a relationship between x and y values, which statement about the relationship is true? So I'm going to go ahead and just kind of connect those dots, make it a line. Now, I see that this crosses the y-axis right there, and that is not the origin, which means that this is not proportional. Remember, we talked about 2 main important things to define a proportional relationship. The first thing is that it has to go through the origin. Well, I guess the first and most important thing is it is a linear relationship, meaning it is a straight line. And the second thing that it has to do is cross the origin. Those are really the only two things we have to look for. And it is a straight line, so it did check this one off, but it does not cross the origin, which means that it's not proportional. So let's read through our examples. It cannot be proportional because the straight line through the points does not go through the origin. I'm going to put a little happy face right here because that sounds pretty right. It must be proportional because the points lie in a straight line, and I know that this is not true because I know this is not a proportional relationship. It cannot be proportional because the y values are not whole numbers. Well, y values being whole numbers doesn't matter. It either has to go, or it has to either, has to go through the origin and be a straight line. So this is not right. It must be proportional. Well, I know it's not proportional. So then our answer right here is it cannot be proportional because the straight line through the points does not go through the origin. All right, last one. We want to read the situations in the table below and drag a graph and an equation to represent each situation. We want to indicate whether the relationships are proportional or non-proportional. So it cost a company $4 to make each t-shirt. Well, if I make 0 t-shirts, then I've made 0 money. It cost me 0 money. So that tells me off the bat, that's going to be in my graph. Well, that's the origin. So I'm thinking that this has got to be proportional, which means my equation would be multiplicative. So it would be y equals 4x because it's $4 per each one t-shirt. And then I'm going to choose this proportional graph to arrow over here. Now, Lindsay's brother is 4 years older than she is. Well, if Lindsay is 0, then her brother has to be 4. So that's not the origin. So this is non-proportional. And I can find Lindsay's brother's age, which is y, by taking Lindsay's age, x, and adding 4. Which means matches this graph right here. All right, guys, that is our lesson on proportional reasoning, proportional concepts. If you have any questions, please email me.